Hi friends, welcome to Physics Live with Ankan Bhattacharya once again. Today I am not going to discuss the physics, rather I am going to discuss some numerical methods which must be employed to solve many physical problems. So the name of today's discussion is numerical solution of ordinary differential equation, or you can say it by simply calling ODE. So what is the need of numerical method for solving ordinary differential equation? As because we have already learned in our mathematical physics that there are various possible ways of solving the ordinary differential equation, such as separation of variable, um, substitutional method, linear differential equation method, linear method so called, in which the integration factor, sorry, if gets involved. So all of these were some analytical method which cannot be applied to solve through computer programming, but it is a numerical method by which you can easily run a program to solve the ordinary differential equation where the problem becomes too hard to solve analytically. Okay, so there are various possible methods present for the numerical solution of ODE, and we can classify the methods in two types. The one, IVP, means initial value problem. Initial value problem. And the other one is BVP, which is called to be boundary value problem. Boundary value problem. Okay, so when we can say the problem is initial value problem, and when we can say the problem is boundary value problem. So to understand this, we have to consider some differential equation. Rather, we can generally say that you have to solve this kind of differential equation, which must be first order and first kind. Here in this lecture, I am going to discuss the numerical solution of the first order and first degree differential equation. So the order of the differential equation is 1, and also the degree of the equation, differential equation, is 1. Let us suppose it is some kind of function of x and y. So this is the given problem which we have to solve. Now, if at some initial point some value of y corresponding to some initial value of x is given, and you are set to solve at some other values, sorry, what is the value of y at x equal to x3? Suppose it is a problem which you have to solve. So for this case, you have given only some initial condition, and from these you have to find out the solution curve present in the xy domain. So if we plot x-axis and y-axis here, you can get a solution curve corresponding to this differential equation, and you are given that at x equal to 0 Suppose at x equal to 0, the value of y is given to you, and you are asked to find out the value of y at this point corresponding to this x point. Okay, or you must have to find out the value of y at corresponding to this x point. So if you are able to find out the solution curve, then by the interception on the axis, or yes, by the interception on the axis, you can say the value of y from the curve easily. So from the initial condition you can get the solution. If this is possible to you, then the problem is initial value problem. But if you have two conditions, one condition is at this extreme point and the other condition at this extreme boundary, and you have to find out the solution curve within this region only. What I say? Let's repeat it. Suppose you have some problem, differential equation to solve, and you have the value of y at one extreme point, and you are asked to find out the y at other extreme point, and in these 2 points, between these 2 points, the nature of the solution curve you have to find out. Then the problem is called the boundary value problem, as because the two boundary values of the y is given to you, and you are asked to find out any solution corresponding to the intermediate region between them. So for the initial value problem solution, you can apply various method such as Euler method, modified Euler method, modified Euler, RK2, Runge-Kutta second order, as well as RK4. These are various possible methods present to solve the ordinary differential equation. Obviously it is first order first degree for initial value problem, and for the boundary value problem you can apply the shooting method, which is very much famous for its applicability, shooting method and finite difference method, etc. These are various methods present. Finite difference method. These are various methods present to solve the ordinary differential equation. If you are asked to solve it by initial value problem, then you can apply these laws, or if you have asked to solve the problem by boundary value condition, then you can apply these two laws. Okay, so in this lecture, it is the lecture 1 corresponding to the numerical solution of ordinary differential equation, and in this lecture I am going to the basic Euler methods, which is the basic of all kind of initial value problem solution methods. So I am going to discuss the Euler method, and after which I can discuss the modify Euler method, and after that we can discuss the RK2 and RK4 and so on. Okay, so let us see what kind of method employs here. Okay, so what I am telling that I can solve or we can solve the ordinary differential equation numerically by the help of Euler method, which is the basic preliminary numerical method to solve. Okay, so before discussing this, let us uh, discuss this kind of differential equation. So let us write further. So here it is a general differential equation which must be solved. So you have to keep in mind that it must have satisfied some conditions which are known as the Lip's Lipschitz condition. So the problem must satisfy the Lipschitz condition to get solved. Lipschitz condition. Okay. So what is the Lipschitz condition? 1 minute. Okay. So what the Lipschitz condition is? Lipschitz condition can be given by the first condition, if x y is defined and continuous in D. What is D? D is some xy plane. XY plane, which I have designated as D. Okay, and x0 y0 is some the condition employed here. So x0 y0 is some point present in this xy plane that is in D. So I can say that D, the region which containing x0 y0. Otherwise it cannot be solved. The initial condition, if the initial condition is not present there, then the solution is not possible after all. So it is the first condition to get solved the differential equation like this. And the second condition is there exists a constant L such that mod if x y1 if x y2 must be less than or equal y1, sorry, this is mod y1 minus y2. So the function at the point x comma y1 and at x comma y2 must be less than equal to the constant multiplied by the difference between the y1 and y2. So these are two conditions that must be satisfied by the differential equation so that it can get a solution. Now the sequence of the solution can be obtained by this, by some discretization of x within the domain, and each x, suppose this is x0, each x is separated by some step size h, let us say, so that this is x1, this is x2, such that x1 is x0 plus h, x2 is x1 plus h, which means x0 plus 2h, and so on. X3 is x0 plus 3h, and so we can write that xi, ith position of x, is given by the initial position plus some I into step size h. These are called as, this sequence of points are called as mesh points. Mesh points, where h is the step size that I have already said to you. Let yi is the approximate solution of the equation 1. So let yi is the approximate solution, that is it is given y okay, so y at the point of xi. Suppose yi is the solution and we have to find out the value of yi. Okay, so Let us now discuss the actual method of Euler given by Euler. Okay. This method involves the solution in a tabulated set of tabulated values. In single step method, we have to define a function which is dependent on xy and also the step size h. We have to find out this kind of function. How? So it depends upon the step size h and also the derivative of the function fxy. So this. So again you can write that fx plus h is yx plus h into phi. Suppose this is the relationship between the y and phi xy, and any higher order of h is neglected, and in single term we can write of the order of higher power of h, where p is positive integer. Let us put it as equation number 2. Okay, so here lies the relationship between the y and this new function phi with the step size as well as the general solution. But we know by Taylor series expansion that the value of yx plus h is nothing but yx plus h y prime x. Y prime means simply the dy dx. Okay, and y double prime means d2y dx too. You are well known to this. So h y prime x plus h squared divided by 2 factorial y double prime x and so on higher powers. If you want to write the higher power, then you can write like this way: y pth derivative and from Maclaurin series you also get the significance of the last term, but I am not interested to the higher power. I will only concentrate to these three terms, but for your knowledge I want to write this x plus theta h. Sorry, x plus theta h. Now what is theta? Theta lies between 0 to 1. These terms are not required for our purpose, but for your discernment of knowledge the terms are given. So by approximate method you can only concentrate these terms only. So you can compare the equation 2 with this new equation number 3, and you can write that phi is nothing but the derivative of y with respect to x. So what I can write? I can write phi xy h is nothing but y prime x. Y prime x means dy dx, dy dx, and dy dx means from equation 1, what is it? F xy. Okay, so although I have written it is a function of xy h, it is nothing but the function of xy only, which gets some term h present as the product form. Okay, so again you are known to this that y at xn is given by yn. So similarly you can write that n plus 1 1th value of y is given by its value of y at x equal to n plus 1. Okay, Now x equal to n plus 1 means from this x3, if x3 be x2 plus h, x1 be x0 plus h, x2 be x1 plus h, then what is the value of xn plus 1? It is nothing but xn plus h. Since the division of x, sorry, the domain of x is equally divided with the step size h, since the domain of x is divided in equal parts with the step size h, so you can write that xn plus 1 is nothing but xn plus h. So put it in this equation and you can write y at xn plus h, where n may be 1, 2, 3 and so on. It can also involve 0 also. y1 means y at x0 plus h. 0 can be also there. Okay. So then neglecting the higher terms, this and this, we can compare the yn plus h. Okay. So from this, putting x is equal xn and neglecting the higher terms or last higher terms, what I can get that y at x in plus h is y at xn plus h into f of xn comma yn. Okay, so this is nothing but yn plus 1 from this equation, and this is nothing but yn from this equation. So at last I can write that y n plus 1 is nothing but yn plus h in h f xn y. This is the main equation to solve the differential equation by the Euler's method. So if I wish to write it in fresh way, so we can get that yn plus 1 is nothing but yn plus h f xn yn. Sorry. This is the general recursion formula for Euler's method which is a single step method for of order 1. Okay, but the truncation error of the Euler's method, the truncation error can also be present in Euler's method, which is given by the higher term, which I have neglected, h square by 2 factorial y double prime x n plus theta h, where theta is ranging between 0 to 1 and n is 1, 2, 3 and so on. Okay. Now let us discuss the geometrical illustration. Geometrical illustration of Euler's method. For this, I must have two-dimensional axis. Okay. So suppose this is the xy axis, that is the d xy plane, which is defined as d, and the solution of the equation 1 can be given by the curve like this. Let us suppose it. Okay, and the solution is nothing but y as a function of x. This is the general solution. So let us say that the initial condition at x equal to x0, you have some value y, which is nothing but y0. So the length of it is y0. Okay, and at x equal to x1, let the value of y is y1. I must have to point out these 2 points as P and Q. So P point is x0 comma y0 and Q point is x1 comma y1. Okay, so you have to find out the general solution from this graph. For this is x equal to x1, which I have plotted, and the length is y1 also. Okay, so at first I have to find out the slope of the curve. For this we must have to draw the tangent at the given point. Yes, at the initial point x0 y0, I have drawn a tangent, and from this tangent you can calculate the slope of the curve by drawing an axis parallel to the x-axis. Yes, and the angle made by the tangent with this x-axis gives the approximate slope of the curve, which can be given by tan theta, which is nothing but this is what? Delta y. Delta y means y1 minus y0, and this is what? Delta x. Delta x means delta y by delta x, and delta x means x1 minus x0, which is nothing but the step size h. Okay, so from this you can get the equation of or approximate solution of y1, since x1 and uh, x0 and x1 is very close to each other, and it must be very close to each other. The reason I would like to say after some few moment. So it must be very close enough, that is x0 and x1 is very close to each other, so that the value of h is very small, and y0 and y1 is also close together, so you can imagine these portion of curves to be a straight line. Okay, so for this you can calculate the y1 by y1 is nothing but some y0 plus the slope, that is dy dx, y equal to mx plus c from this equation. So y0 is the interception, and this is the slope at the point P, and the small dg and small spread of x, delta x. Okay, now what is the value of dy dx at P? This is given by this at P, and the dy dx is nothing but the fxy, which was given in the equation 1, and the curve is the solution curve of these equation, which I have shown already. That, yes, sorry, yes, this is the equation 1, and the curve is the solution of this equation 1. So from equation 1 you can write that dy dx at P must be equal to some f, P means x0 y0 into delta x, and delta x is what? Delta x is h, so you can write y1 is y0 plus h f x0 y0. This is nothing but the okay, so after some generalization you can write that yn plus 1 is also equal to some yn plus h into f at xn yn. So this is nothing but the general recursion formula of Euler's method. So from geometrical illustration you can also get the same result as obtained by the analytical numerical method. Okay, so after discussing this, you must have to keep in mind that this method contains some limitation or disadvantage. So disadvantage. What is the disadvantage of this method? This method have the great disadvantage in the step size h, which employs in the value of y. If the step size be not be very small or the step size be very large, then our actual value of yn plus 1 will deviate from the true result that can be obtained by analytical solution. Okay, So if the value of h must not be small, then the value of y becomes erroneous. So that I can say in the before some minutes that h must be very small. Otherwise, the solution of the equation becomes erroneous. Okay, this is the first point. And if the second point is if h be very small, then you can see by picking up some example that the solution becomes very laborious or very time consuming, and that cannot be solved in a few seconds. It may take a large time to solve by this process of the differential equation like this one if the h has a value very small. Okay, so the disadvantage is very bigger thing to know, so that the modification some modification is done in this process to reduce some erroneous solution, which must be replaced by some modified form, which is given by modified Euler form, and later RK2 RK4 also developed to remove this error from the solution. So let us pick up some example to solve the uh, differential equation by this process. So let us pick up some problems. At first I would like to pick some very simple problem like problem solve dy dx is equal some x plus y. Let us pick this type of problem. So okay, the question is not complete by Euler method. Provided the initial condition is y is equal 1 at x is equal 0, and you have to solve, you have to find out the value. So the question must be modified given, let us say given, and by Euler method. Okay, so by Euler's method find y at x is equal 0.1. Okay, so here the step size is not given. Yeah, step size is not given, so you have to determine the step size. But how can you determine the step size? uh, as soon as you are not known to the step number, in how many step number the x should be divided. So assume let us assume the step number in to be equal to 5, then the step size become final. Okay, if x equal to a is given and x equal to b, you have to find y, then the step size is given by b minus a by n. So here 0.1 minus 0 divided by 5, so the step size becomes 0.02. Okay, next the thing is that you have to tabulate, as because I have said that Euler method is a tabulated method. So x0, x1, x2. What is the value of x0? I think 0 is given. Yes, 0. And x1 becomes x0 plus h, so 0.02. x2 becomes 0.02. x1 plus h, so 0.02 plus 0.02, 0.04. x3 is given 0.04 plus 0.02 means 0.06. x4 is given by 0.06 plus 0.02, 0.08, and x5 becomes 0.08 plus 0.02 becomes 0.10. This is the desired value of x. So at x equal to 0, the value of y will be y0. At x equal to 1, value of y will be y1. At x equal to 2, value will be y2. So on. So on. And you have to find out the value of y at x equal to 0.1, which is the value of y1. It should be find out. For this, you have to determine these, and these. So main problem is understood very well. So I must put some space. I must have to put some space to write the solution. Okay. Okay, so what is the value of y0? y0 will be, y0 is given by the initial condition 1. Okay, and the y1 will be given by, so it is value 1. y1 is given by y0 plus, so here n0 is excluded, as because you must have the given condition y0, otherwise you cannot solve for that. So y0 is not included. Okay, no, 0 must be present here. I think it was a printing mistake from where I have studied. 0 must be included, otherwise you cannot solve. If y0 is not given, y1 how can be calculated? So it must include 0. So there was some printing mistake, I hope. As because here y0, if y0 was not given, then how can you calculate the y1 for that? Okay, if the answer is somewhat different, then you can write them in the comment box so that I will understand. So y1 is equal y0 plus h into f of x0 y0. So here the function dy dx is given by x plus y. So if xy is x plus y, so here it will be y0 plus h into x0 plus y0. Y0 has a value 1 plus 0.02, x0 0 plus 1 means 1.02. So it is the 1.02. Similarly, you can calculate y2, y1 plus h into x1 plus y1 means 1.02 plus 0.02 into x1 0.02 plus y1 1.02. So 1.02 plus 0.02 into 1.04 means 1.02 plus 0. So 1.02 and 1.04 into this. So 8 0 2 2 2 1 2 3 4 0.028, and you can get 1.0408. Okay, after proceeding further, the calculation will be difficult or time consuming. So I have choose the step size 0.02. It is small as compared to 1 2 etc., but it involves some laborious work to calculate the y1 y2 y3 and further. If I must have to choose age is very small from this also 0.02, suppose 0.02002, then the solution will also be difficult from this one. That is why this is a great disadvantage of the Euler's method. Again, if you not choose the age to be small, then the solution of y becomes errorful. Sorry. That is why the disadvantage I have shown above. These are the disadvantage of the Euler's method. But you have to solve this by Euler method as you are asked to do so. So y2 plus h into f of x2 plus y2. From the help of the calculator, you can write this as it will be 1.0624, and y4 will be, so it is 1.0408, it is 1.0624, and y4 will also be y3 plus h into x3 plus y3, and the solution, sorry, and the solution will be 1.0848, 1.0848, and y5 will also given by y4 plus 0.02 plus x4 plus y4 means 1.1081. It can also be obtained from the calculator. So the value, the desired value will be 1.1081. So we were asked to find the solution of y at x equal to 0.1. So at x equal to 0.1, the value of y is this. This is the actual answer. So in this way, we can solve the first order first degree ordinary differential equation through Euler's method numerically. This can also be done as you have it is already shown to you that this is a very long process for analytically determine the value of y, but it is very simple if you apply the same method in programming, so that the computer will give you the answer after some few seconds. Okay, so uh, in later we can show the solution of this same differential equation by Euler's method in Python programming. Till then, uh, try to memorize or try to understand the things which I already discussed to you in this lecture. It is not a difficult thing to understand, but uh, at first time you must have some time to understand this. Thank you very much for watching and for being with me like this. Your support will help me to make such videos in later. Thank you. If you enjoyed, then hit the like button and subscribe the channel for more updates.